So, as it's the last presentation of this case studies, I will try to focus on the most important issues that we have developed and we are planning to develop. And in this case study, we have used a multi-purpose platform, multi-use platform, combining renewable energy sources. It's wind turbine, but it's also photovoltaics on the platform, and desalination of seawater. So the company was established, a few words about the company, back in 2007. It's a spin-off company established by some universities, private firms, and some individuals to exploit the technology that was developed after some years of research. And we collaborate closely with many external partners, such as universities, enterprise, renewable energy organization, ministers, etc. And we focus on three segments for customers. One is the local market, which is the Greek island. And the other is the European, for example, Cyprus or Canarias. And the global market, because we have some contacts with Caribbean and the Middle East, and they have similar needs and questions. So when we started, we want to find a solution for energy and water shortage in the islands. So there is, of course, we don't have such problem here in Ireland or in UK or North Europe about water, but in our area, in many areas of the world, this is a big problem. It's the #1 problem. And when we design the solution, most of the people ask why to use renewables, or why to go offshore, or why to combine both of them in one platform. So very quickly, it's as they do it now in the Greek islands, they transport water with boats. So there's a big cost on that. It costs about 15 euros per cubic meter, which is huge. And if you don't want to do that and do a traditional desalination system in the island, then the cost of electricity is high because they burn oil to produce electricity. So it gives you a cost of water more than an actual cost more than 4 euros per cubic meter, which again is very big. And there are many environmental issues. For example, in this picture on the left side, you can see an existing installation in Syros Island. So on the picture above, you see they burn the oil, so there's a pollution, it's dirty installation, and then you have also the brine disposal, and dispose all this with the chemicals near the shore and they destroy the environment. On the other side, you have a more clean solution. So why to go offshore? The first picture on the top shows the island of Santorini, which is one of the next case, the first case that we have studied with the Maribe people here. So you see where to put the wind turbine. I mean, in the second line of the pictures, there are some pictures from some campaigns against, local campaigns against the putting of wind turbines on the islands. So of course they have overemphasized the size of the wind turbines. It's not, on scale, but you should not underestimate that the people that are living in the islands and they are living out of the tourism, they have a strong opposition in putting on land such things. And of course, even if you decide to do that, then you need to, for example, imagine you have a wind turbine on the top of the mountain, and then you have the desalination plant near the sea. So you need to open some roads to bring the turbine up, and this also destroys the environment, but it's a big cost if you want to put one wind turbine and not a whole part. And then you have to, and the connection cables, and they are not happy with that. You see there is some project about burying the existing cables so then not to have a visual impact. And in the picture here you can see the port of Santorini. So you understand that it's not possible to move a big wind turbine in such an island. This is the street that goes from the port up to the island. So it's not possible, simply. And you don't have infrastructure. You have roads. You don't have cranes to move the things. And the wind speed, of course, is better. You know that in the sea. You have these electricity problems in the island. So if you put more consuming of electricity, which is traditional desalination system, then you have blackouts with all the implications. And you have a lack of space. So the proposed project with the Maribe people has two stages. One is to deploy 2 kilometers of the coast of Santorini platform, multi-use platform with wind turbine of 0.8 megawatts. The depth there is about 100 meters. And the second project, the second phase of the project, is a commercial unit with 2 megawatts wind turbine. We are not in favor of building very big, huge systems for many reasons. We are more focusing on providing some solution, distributed solution to different places. The advantages is we use 100% renewable sources, no fossil oil at all. We're independent of the price of the oil and for exchange rate. Because we build this in shipyard and we moor it inside, then we have cost reduction. Also, we have the ability and thoughts to engage with other blue economy sectors, like, for example, aquaculture. Some technical issues about how you match the available power using the potable water as a way to store the energy when you have excess of energy. We don't use chemicals, so the brine is not polluting so much. You can go to different water depths, and you can transport the system if you don't like and you want to change. So prior to the engagement of the Maribe project, we have developed a project, a prototype, a 30 kilowatt wind turbine with 12 kilowatt photovoltaics, and we have designed, delivered it, and work on that. We have a second phase where we have optimized the system. We started the company to exploit the technology, and as a general remark, we can say that we have success in all technical issues, and there are a lot of difficulties we have to overcome because we have to combine both technologies on one isolated system. But we have not succeeded business-wise, and the main reason for that is, we believe it's that first is the financial situation, which was unstable all these years in Greece and still remains to a certain extent unstable. And the reason that all these projects, they need much money in the beginning. You have all these capital expenditures, so it's very difficult for the investors to decide in an unstable situation to put a lot of money, even if they have a contract for 20 years or so. So we think that that was the basic reasons that we have not succeeded in that. Working with the Maribe people, we have, thanks to their experience, they have developed a business plan for a pilot and a commercial system, and we have some feasibility studies about how we move from 30 kilowatts to 800 kilowatts, and then to the second phase to 2 megawatts. And On the left side, you see all the figures that I said before. We have made a detailed analysis with the Maribe people, and we derived to these results, which is that this combination, this offshore combination, is competitive technology compared to existing onshore desalination units, at least in the islands or in the parts that where you don't have cheap energy, or you have expensive energy, and it's a lot of places there. Of course, it's very competitive compared to existing solution for transfer water. So we have developed a realistic and achievable plan. We have explored partner opportunities together with Dimitris and Mike. We have discussed with some people outside the consortiums that are interesting, and we have explored combination opportunities with other applications, like I said before, for aquaculture through the future collaboration. So the benefits gained from the advisory session is that, I mean, their comments, recommendation coming from a variety of experts were very valuable, because we understand what are the questions that they have before, because if you know your technology and your project, you believe that the others knows some basic things, but it's not the case. So you have to start explaining why this is needed, and to make people understand that it's a big market, and then proceed to the details of the project. And we have, of course, these B2B meetings, which were very useful, and the debriefing session and the opportunities we have discussed for collaboration. We have clarified and improved, in light of the comments, the project, and we have revised some actions. So as a future collaboration, through the Maribe involvement, we have already discussed with Aquabiotech about possible future collaboration, and we have discussed with Principal Power Corporation, which is a big company who has made in Portugal some installation floating structures, and we have discussed possibilities for cooperation. So the idea with the aquaculture is that we have a floating structure, as you can see here. So underneath, below that, you can put the aquaculture cages, and you have all what you need to have an automatic system for feeding, for example, like here, for feeding the fishes and monitoring a lot of things. So you share the same existing infrastructure to another application, so you have more benefits. So thank you for your attention. I want to thank also all the Maribe partners for their help, and special thanks to Dimitris and Mike for their time that they spent and the work they have done with us.
Well, this project was a last request from the DGs, because we didn't initially consider desalination as one of the sectors to be involved, but it was actually requested by Jacques Fuchs. He said that there should be lots of potential for desalination that's made offshore. Could you describe the market potential? You've talked about the application in Greece. Where else is desalination going to be a hot property, or renewable energy desalinated water?
Okay, I mean, in all the Mediterranean countries, I mean, both in Africa and Europe, they have shortage of water. We have contacts from the Caribbean, some Caribbean islands, for example, from Haiti, from Antigua, Barbuda, and they want such solution, because the cost of water is very high also there, so you can achieve it very competitive. In Cyprus, Malta has problems. I mean, everywhere that, in all the places that you use desalination with a traditional way, you can use it better with this combination.
That's great. Any questions then? Hannes?
I've been working on a similar project, not using wind, but wave energy on all the Chinese islands north of Hong Kong, 2,000 islands, with exactly the same situation. But we found out that we couldn't find a cheap solution for desalination offshore. It was much cheaper to do that simply just in the harbor area. And so you produce electricity by the wave or by the wind and send that ashore, and then you are using that electricity for the desalination. Why is your system cheaper than that? Where is it cheap to use desalination offshore? I mean, including having a pipe bringing onshore.
Yes, okay. This comes to the question, which energy is cheaper? Is energy coming from wave devices or is energy coming from offshore wind turbines? So, okay, if you have a solution with cheap energy from waves or from elsewhere, okay, it's okay. But still, you have, if you have a standalone system, I mean, not connected to the main grid, and you want to put together the two technologies to work, you have to overcome a lot of difficulties, technical difficulties, not mentioned, but you have to do that. So we have done that. In the projects in the Caribbean, they were asking us to incorporate also wave devices because they have good waves there. So it depends. If you are in a place that you have good waves, so cheap production from the waves, energy production from the waves, maybe this is a solution that you mentioned.
Mike, do you want to comment on the cost benefit of moving offshore in comparison to a land-based desalination unit?
Well, there isn't, but the case that's made is that you can't simply just put a desalination plant necessarily on shore because of the pressure of the land use. But I think Liz needs to say a bit about your desalination kit.
Perhaps it doesn't.
Perhaps it doesn't.
So do you mean so it's not that it's cheaper to put it offshore, but it's the cases when it has to be offshore?
Yeah, so yeah, you could say you would feed electricity to a site on shore, but then where is the site on shore? What they have, particularly in Greek islands, is you already have storage in the harbour, so you can pump into that storage. And you saw the Santorini harbour, there's not much space for putting things in that harbour. So by putting them together, you offer a solution that you can offer together to somebody as a package, and I think that has some value. But you're right, if you put the desalination plant onshore, it's always cheaper to put something onshore if you haven't got rocks and very steep-sided places where there's more pressure to maybe build a swimming pool than there is a desalination plant. Yes, it's the desalination plant that you showed could look quite messy and horrible and not necessarily the best use of land for that community. Does that make sense?
Python?
Question on LNG terminals. You have desalination, electricity, and you can recuperate the flume from the salt from the flume to be recycled and used as for packing fish, for example. A mobile system that floats is available on the market. It's just a question of how can it be fitted into the Greek system of islands and population support.
I think the value of this particular exercise, you've shown that the cost of the product that you're producing is still affordable and is still much cheaper than if it was produced by diesel. So
Yeah.
Diesel is and so if you had to go offshore, your renewable energy produced product is more competitive, and that's the value. So this exercise has proven it.
Okay, and also the idea of using also the aquaculture together is to provide some small scale, let's say, solutions which are on the scale that is needed for a small community in the island, so you can they can produce by themselves energy that they need, water they need, and also provide some jobs for the local people in the aquaculture sector. So we are more in favor of developing smaller system, distributed system for different communities, rather than going for a huge park with a lot of things on that. And this is also because the Aegean Sea is not the ocean, so you have to see what the local needs are. So it's a big market for small communities like this. I mean, even not in Greece, even outside, even in Norway, although they have a lot of spaces, they have different communities, so they need distributed systems. They may need distributed systems for the local communities to work on that and take their needs and have some jobs there.
Okay, thank you very much.
Okay.
Now we're going to move on to the final phase, which is the second panel discussion. So I'd like to call the panelists, please, to sit at the table, and we're going to discuss the theme, which is the Maribe process. What is the Maribe process? It's been called a business accelerator model type process, where we brought companies in various different stages of involvement when they came to us to a step further in the business model development, and we wanted to assess and discuss the real value of this process and whether this could be carried forward and how can it be carried forward for the Commission. So we have Mike, Demetrius, Hans, and member from the Campbells. Who wants to? Everyone's familiar with the panelists so far because they're other companies or partners, but we have an extra member here that's joined us today, Neil Kenny, and let's just briefly introduce yourself.
Hi, my name is Neil Kenny. I'm from Peak Energy. We're an independent renewable energy development company, and we have a large interest in the private sector and I suppose a growing interest in the floating wind sector. So I've been following closely all the projects that we're interested in. It's been very interesting so far.
Neil was on the advisory panel in Brussels for day one only. Unfortunately, she had to leave the second day. That's why many of you may not have seen Neil. She gave very insightful comments to the companies that she did review. And so glad that you came to review all of them today. So I'm going to start off with talking to the companies, and that will be